Hi everybody, so today we're going to be talking about that second part of functions. So you should be on the notes that say 2.1 Part 2 function notation. So let's review. I think most of you are familiar with function notation. First of all, up till now we would write basic functions in the form y equals. So in this case, y equals 3x plus 2. And now we can write this with I like to call fancy notation. And the fancy notation is we're going to replace the y with f of x, this piece right here, this f of x. And it's just a new name for y. So you can always think that f of x equals y. And you might be thinking to yourself, how is she saying that? This notation is actually read f of x. Or sometimes some teachers will say f at x. Either way, you have to make sure you know that it does not mean f times x, okay? It's just a new way of writing y. All right, so let's look at how this is going to work for us. The normal way, or this old way that we've looked at coordinate points, we would write them as ordered pairs, and we'd write them with x, y's. But since we're not using y anymore, the coordinate point 1, 5 would be written this way. We would say f at 1 is equal to 5, or f of 1 is equal to 5. All right, let's look at an equation. The old way, or what we've been working on, is we'd give you an equation, y equals 2x minus 1, find y when x equals 3. Okay, so this would be find y when x equals 3. All right, so how are we going to ask you that same question with function notation? Okay, so we're going to give you a function, f of x equals 2x minus 1, noticing that f of x is in the same location as the y in the original example. And we'll say find f at 3. And so basically all that means is take the 3 that's in there and replace the x with it. So we would do 2 times 3 minus 1. And we get 6 minus 1, which is 5. So our answer would be f at 3 is equal to 5. Now, even working backwards, we need to realize that that is actually a coordinate point. The coordinate point would be 3, 5. And so going back, thinking about it like this, f of x equals y, you can see that the 3 is in the x position and the 5 is in the y position. Okay, so let's try that. So we're going to give you two functions. Now, I can use f of x to give you one function. I can also use any other letter, like something like g of x, or I could use h of x, or I could use c of x. Doesn't really matter. It means the same thing. Okay, but it tells me which function I'm dealing with. So for the first example, it says f at 2. It says find the following. So f at 2, that means I want the f function, which is this one. And we're going to take the 2. We're going to replace it anywhere in that function that there's an x. So 3 times 2 minus 2. So 6 minus 2 gives me 4. So then f at 2 is equal to 4. All right, g at negative 3. Okay, so now we go to the g function, and we replace negative 3 anywhere there is an x in the function. So we're going to do negative 3. Since we're plugging it in, we're going to make sure we put parentheses. We've been talking about that all week. All right, and then add 3 to it. All right, when we have an expression, a negative expression raised to an even exponent, and it's in parentheses, negative 3 times negative 3 will give me a positive 9. 9 plus 3, and we'll get 12. So g at negative 3 is equal to 12. All right, one more. F at 4, again, we're going to replace the x with the 4. So 3 times 4 minus 2. Okay, so we get 12 minus 2, which is 10. So f at 4 is equal to 10. So f at 4 is equal to 10. Again, that's a coordinate point. Think of it. The coordinate point would be 4, 10. Okay? All right. Now, I'd like you to try D and E, and we will check those tomorrow in class. And we're going to hold off on F. I'm going to talk about F when you come back to class. Now, it might be missing from your paper, but we're going to look at one harder example. So a harder example. A harder example would be something like this. What if I say, find, or f of x equals 0, find x? Now you may notice that in all these other examples, there was a value in here that I was plugging in. But now I've got it set equal to 0. So now if I really think about this, and f of x equals y, then this is saying replace y with 0, or set the equation equal to 0. So for this example, we would do 3x minus 2 equals 0, and then solve for x. And that's why it's saying find x. So we'd add 2 to both sides. We'd get 3x equals 2, and then we would divide by 3. So then x equals 2/3. So f at 2/3 equals 0. So do you see how we did that and how this is different? This expression is different than the other ones we did. So we want to make sure you understand that. All right, now the only way this can get a little bit harder is to look at it using finding function notation values from a graph. All right, so here we have the graph of a parabola, and I want you to write that down again. It's a quadratic function because we're going to be talking about quadratics a little bit later this year. All right, if I want to find f at 1, well, we know that that's the x value of 1. So I'm going to search the graph for the x value of 1, which is right here, and I'm going to find the y value, which appears to be -2. All right, let's look at the next one, f at -2. So f at -2 is right there. That's the x value at -2, and the y value at that point is 0. All right, we keep going. Now we're looking at f at 0. So we go to our graph, and here's f at 0 right here. And so that's the x value of 0, and it appears that the y value there is -3. Okay, so that's how you do it on a graph. Now, the next one says, find f of x equals 0, find x. Now remember, this is in the form f of x equals y. So now I'm giving you the y value of 0 and asking for the x. Well, the y value of 0 is, there's a y value here of 0 and a y value here of 0. So in this case, my x's would be 2, or -2 and 2. So there's 2 different values where f of x is equal to 0. All right, one more. I'm going to start this one with you, and then I'm going to have you finish and bring it into class. So g at 1. Now this function is really funky looking. This is called a piecewise function. It's pieces of 2 different functions. All right, so I'm going to go to g at 1. So I'm going to go to the x value of 1. And it looks like there's a closed circle there at the positive value of 1. So g at 1 is equal to a y of 1. All right, let's do another one, g at 3. So I'm going to go to the x value of 3, which is right here. And I'm going to go down to the graph, and it looks like g at 3 is equal to -3. All right, what I'd like you to do is I'd like you to find g at -5 and g of x equals 0, and bring those into class tomorrow for us to check. All right, hopefully this wasn't too bad. Nice short video. See you tomorrow, everybody.